Dear friends, welcome to Bond with Arctic Chemistry YouTube channel. In this video, I am going to explain the previous year's questions appeared in HCU PG Entrance Examination from Chemical Equilibrium from the years 2010 to 2013. In the following reaction scheme, A gives rise to B, B gives rise to C. Which of the following determines the rate of formation of C? Here there is an equilibrium between A and B. What is the rate of formation of C? Rate of formation of C is equal to K3 into concentration of B. From this equilibrium, capital K equilibrium constant is equal to forward rate constant K1 by backward rate constant K2 is equal to concentration of B by concentration of A. So that implies concentration of B is equal to K1, K2 into concentration of A. So in place of B we can substitute K1, K2 by A. So R is equal to K3 into K1 by K2 concentration of A. So finally, rate of formation of C, this one depends on K3, K1 and K2. So the correct option is D. The molar concentration of Ag plus ion in a solution having PAg plus of 6.372 is. The potential of Ag plus is equal to minus log concentration of Ag plus. So here molar concentration of Ag plus you have to find out. PAg plus is given. So concentration of Ag plus is equal to 10 to the power of minus PAg plus. So 10 to the power of minus 6.372. This one is equal to 4.25 into 10 to the power of minus 7 molarity. This is the concentration of molar concentration of Ag plus. So A is the correct option. A mixture of 1.20 mole of X, 2.10 mole of Y and 0.950 mole of Z is found at equilibrium in a 1 liter vessel as shown below. What is the value of the equilibrium constant K? To calculate equilibrium constant K, we have to know the equilibrium concentrations of Z and also equilibrium concentrations of X and Y. K is equal to, equilibrium constant K is equal to, it is a ratio of concentration of product and concentration of reactants. Here number of moles of X, Y are given. When you divide with the volume, you will get molarity. So this one is 1.20 molarity. Y is also 2.10 molarity and Z is 0.950 molarity. So K is equal to 0.950 divided by 1.20 into 2.10. So when you simplify this equation, you will get 0.377. What is the percent dissociation of acetic acid if the solution has a pH is equal to 4.74 and the pK is equal to 4.74? We have to calculate the alpha value. The same question was asked in HCU 2017 examination. In part 1, I have given the solutions to this question. So please watch the part 1. You will get the solution. The answer is 50%. What is the pH of a solution prepared by mixing 25 ml of 0.1 molar CH3COOH with 25 ml of 0.05 molar CH3COO-Na? Assume that the volume of the solutions are additive and that the pK and that the K of CH3COOH is 1.8 into 10 to the power of minus 5. According to Anderson's-Hasselbalch equation, pH is equal to pKa plus log concentration of salt A minus by concentration of weak acid HCl. Here K is given, Ka is equal to 1.8 into 10 to the power of minus 5. So pKa is equal to minus log 1.8 into 10 to the power of minus 5. pKa is equal to around 4.74. And concentration of HCl, this is the concentration of HCl, 25 ml, 0.1 mole of CH3COOH. Initially this is volume, 0.1 into 25 initial volume divided by final volume, 25 plus 25, it's 50. So this one is equal to 0.1 by 2. And the concentration of A minus, initial volume is 25 and concentration is 0.05 into 25 divided by 50. So this one is equal to 0.05 by 2. Okay, when you substitute these values, pH is equal to pKa, say 4.74 plus log concentration of A minus 0.05 by 2. Here A minus is CH3COO minus and HA is CH3COOH divided by 0.1 by 2. So this one is equal to 4.74. It will be equal to log 1 by 2. 2 cancel, 0.05 by 0.1 is 1 by 2. So this one is equal to 4.74 minus log 2. We know the log 2 value 0.3010. So 4.74 minus 0.3010. You can write 0.30. It will be 4.44. So the pH of the solution is 4.44. 10 ml of 0.10 mole of sodium carbonate is added to 20 ml of 0.10 mole of sulfuric acid and the resultant solution is titrated against 0.10 mole of sodium hydroxide. What will be the titer value at the end point? The sodium carbonate solution, if you take, this one forms sodium hydroxide and H2CO3. So finally it's basic. Here the normality of this solution is NB is 0.10 into 2. Since 1 mole of sodium carbonate generates 2 moles of NaOH, so it will be into 2, 0.20, and Vb is 10. So NbVb is equal to 0.20 into 10, it will be 2. And NaVa, normality of sulfuric acid, molarity is 0.10. 1 H2SO4 generates 2 H plus ions, so the normality will be 0.10 into 2 into volume 20 is equal to, this one is equal to, it's a 4. So since NaVa is greater than NbVb, the resulting solution is acidic. So the concentration of H plus is equal to NaVa minus NbVb by Va plus Vb. So this one is equal to 4 minus 2 by 10 plus 10, 10 plus 20, 10 plus 20. So it will be 2 by 30. Okay, this one is titrated against 0.10 molar sodium hydroxide. Then what is the volume of sodium hydroxide? Here NaVa is equal to NbVb. Here Na is 2 by 30 and volume is 30. The resulting volume is 30 is equal to Nb. So what is the concentration of Nb? Nb is 0.10 and you have to find out Vb. So that implies 30 cancel. So Vb is equal to 2 by 0.10. It will be is equal to 20 ml. So the answer is 20 ml. If Kc equals to 0.11 at 25 degrees centigrade for the reaction N2O4 gives rise to 2NO2. What is the Kc for the reaction? NO2 gives rise to 1 by 2 N2O4. Okay, N2O4 to NO2. Okay, let us take Kc as K. If you reverse the equation, 2NO2 N2O4, the K value will be 1 by K. The Kc value will be 1 by K. When you divide with 2, NO2, 1 by 2 N2O4. So here you have to give the power 1 by 2. So it will be root K. Root 1 by K. So here Kc is equal to Kc for this reaction. Kc for this reaction is equal to root over 1 by K. K, this is the equilibrium constant. This one is given as 0.1, 1 by root over 0.11. So Kc is equal to, after simplification, you will get 3.0. At a certain temperature, the equilibrium constant Kc equal to 0.11 for the reaction. What is the equilibrium concentration of ICl if 0.75 mole of I2 and 0.75 mole of Cl2 are initially mixed in a 2.0 liter flask? So this is a reaction. The initial concentration is given. 2 ICl gives rise to I2 plus Cl2. The initial concentrations are given. Initial concentrations are 0.75 mole by volume 2, and this one also 0.75 mole by 2. This one is 0. At equilibrium, when there is a consumption of X amount, so there is a formation of 2X. Here 0.75 by 2 minus X. This one also 0.75 by 2 minus X. Kc is given. Kc is equal to concentration of I2, concentration of Cl2 at equilibrium, and ICl whole square. This one is given as 0.11. So Kc, from this Kc is equal to 0.75 by 2 minus X. This is the concentration of I2, and also for Cl2 also 0.75 by 2 minus X. So it will be square divided by ICl square. It will be 2X square. Okay, when you simplify this equation, this one is equal to 0.11. When you simplify this equation, X will be equal to 0.225. Here you have to find out what is the equilibrium concentration of ICl. Okay, ICl equilibrium concentration is 2X. So it will be 2 into 0.225. So it will be equal to 0.45 moles per liter. So C is the correct option. 40 ml of 0.11 molar HCl is diluted to 100 ml with water and then titrated with 0.1 molar NaOH. The pH of the resulting solution after addition of 10 ml titrant is, okay, 40 ml. Initially 40 ml and 0.11 molar of HCl is taken. It is diluted to 100 ml. So initial volume is 40 and concentration is 0.11. Okay, when you divide with final volume is 100, then you will get a concentration of HCl in 100 ml solution. So it will be equal to, so this one 4.4 into 10 to the power of minus 2. So the concentration of HCl or H plus is equal to 4.4 into 10 to the power of minus 2. What is the pH of the resulting solution after the addition of 10 ml titrant is? Here concentration of H plus NaVa, let us take NaVa, 4.4 into 10 to the power of minus 2 into 100 is equal to 4.4. NbVb is equal to 0.1 into 10 is equal to 1. Since NaVa is greater than NbVb, the resulting solution is acidic, so the concentration of H plus is NaVa minus NbVb by Va plus Vb. So concentration of H plus is equal to NaVa is 4.4, NbVb 1, so it will be 3.4 by, what is the Va plus Vb? Va is 100 and Vb is 10, so it will be 110. You have to calculate pH of the resulting solution. The pH, if you take the pH is equal to minus log 3.4 into 110. After simplification, you will get 1.51. 4.5 gram of PCl5 on vaporization occupied a volume of 1700 cc at 1 atmosphere and 227 degrees centigrade. The degree of dissociation of PCl5 is, okay, this is the PCl5 gas dissociates into PCl3 gas plus Cl2 gas. This is the dissociation. Well, initially there is a 4.5 gram of PCl5. So initially the number of moles of PCl5 and PCl5 is equal to 4.5 by the molecular weight of PCl5 is 208. So when you simplify, you will get around 2.16 into 10 to the power of minus 2 moles. This is the initial number of moles of PCl5. And after dissociation, the volume of the gas on vaporization occupied volume and pressure and temperature is given. So you can calculate N is equal to the total volume, N is equal to PV by RT. Okay, P is given 1 and 1700 cc. 1700 cc means it's 1700 ml. So it will be 1.7 liter. 1.7 divided by 0.0821 into 227 degrees centigrade means 227 plus 273. So this one is 500 Kelvin into 500. So finally N is equal to, you will get around 4.1 into 10 to the power of minus 2. So initial concentration is given. What is the initial concentration of PCl5? PCl5 is 2.16 into 10 to the power of minus 2. It's a 0 and 0. This is initial. And at equilibrium, after consumption of alpha, after the degree of dissociation is alpha, then it will be 2.16 into 10 to the power of minus 2 into 1 minus alpha. It will be 2.16 into 10 to the power of minus 2 alpha, 2.16 into 10 to the power of minus 2 alpha. Then at equilibrium, the total number of gaseous molecules is 4.1 into 10 to the power of minus 2. So the number of gaseous molecules of PCl5 plus PCl3 plus Cl2 will be equal to 4.1 into 10 to the power of minus 2. So 2.16 into 10 to the power of minus 2, 1 minus alpha, plus 2.16 into 10 to the power of minus 2 alpha, plus 2.16 into 10 to the power of minus 2 alpha is equal to 4.1 into 10 to the power of minus 2. So when you solve this equation, you will get alpha is equal to 0.8 into, this is a fraction, then percentage of alpha is equal to 0.892 into 100. So it will be equal to 89.2 percentage. So C is the correct option. Consider the equilibrium X gives us 2y with the equilibrium constant Kc is equal to 3.6 molarity at 25 degrees centigrade. The initial concentrations are X naught is equal to 1.0 molarity, Y naught is equal to 0.0 molarity. The equilibrium concentrations of X at 25 degree centigrade, X equilibrium is. Here X gives rise to 2y. Initial concentration 1.0, 0.0. Let's take, let's dissociate X. 1.0 minus X, it will be 2X. So K equilibrium, Kc is equal to concentration of Y square by concentration of X is equal to 3.6. Concentration of Y is 2X, 2X square by concentration of X is 1 minus X is equal to 3.6. That implies 4X square is equal to 3.6 into 1 minus X and 4 0.9. That implies X square minus 0.9, so it will be 0.9x minus 0.9 is equal to 0. When you solve the quadratic equation, then x is equal to minus b minus 0.9 plus or minus root over b square minus 4ac, 0.9 whole square minus 4ac, 4 into 1 into c is minus 0.9 by 2a, 2 into 1. So you will get minus 0.9 plus or minus root over this 0.81 minus 4ac. It's 4 into 0.9 minus of minus plus, it will be 3.6. It will be 3.6 divided by 2. So this one is equal to minus 0.9 plus or minus, this one is equal to 0.81, 3.6014, 4.41, 4.41 by 2 is equal to minus 0.9 root over 4.41, it will be 2.1. So 2.1 by 2. So let's take plus value. X is equal to, it will be minus 0.9 plus 2.1 by 2, and you will get around 1.2 by 2 is equal to 0.6. So what is the concentration of X equilibrium? What is the concentration X equilibrium? You have to find out. It will be 1 minus X. So X equilibrium is equal to 1 minus X is 0.6. So it will be 0.4. So the correct option is 0.4. 0.6 is X, the consumption X, and this is X equilibrium. So what is the correct option? C is the correct option. What is the hydroxide ion concentration of a solution that has a pH of 11.20? What is the hydroxide ion concentration? So pH is equal to 11.20 and pOH is equal to 14 minus pH. So 14 minus 11.20, it will be equal to 14.00 and 11.20, 0 and 8. It will be equal to 2.80. This is the pOH. So the concentration of OH minus, you have to find out hydroxide concentration. So 2.8, 10 to the power of minus 2.80, it will give 1.58 into 10 to the power of minus 3. 50 ml of 0.04 molar HCl solution was mixed with 50 ml of 0.02 molar AgNO3 solution. Stirred and filtered. The pH of the filtered solution is. Here the correct option is not given. Let us solve this one. 50 ml 0.0 molar HCl. So when you take the reaction between AgNO3 and HCl, there is a formation of AgCl, precipitate, and HNO3. Here there is no change in concentration of H+. Okay, how many number of moles of H+ are there in HCl, that many moles of H+ will be formed. Here the addition of AgNO3 will not change the pH of the solution. So what is the pH? The concentration of H+ is equal to concentration of HCl, that is 50 into 0.04, initially 50 ml, but after addition of 50 ml of this one, the total volume will be 100. So 50 by 2, 0.04 by 2, it will be 0.02. So 2 into 10 to the power of minus 2. pH is equal to minus log concentration of H+. So it will be equal to minus log 2 into 10 to the power of minus 2. So it will be 2 minus log 2. So 2 minus 0.30. It should be around 1.7, but the option is not given. Okay, nearly 2, the nearby option. In a titration experiment, the end point indicates. There is a difference between end point and equivalence point. Okay, equivalence points, it's a neutralization point. Okay, the point at which there is a neutralization takes place between acid and base. End point, the point at which there is a change in color of indicator takes place. Generally, end point is slightly greater than equivalence point. Sometimes end point is equal to equivalent point, so sometimes is slightly greater than end point. So it's not a neutralization point, it's not a completion of precipitation, it's not exact equivalent point, it's apparent equivalence point. It's like equivalence point, near to the equivalence point. So what is the correct option? C is the correct option. The concentration of Ba2 plus in saturated BaSO4 solution at 27 degrees centigrade is 1.04 into 10 to the power of minus 5 molarity. What is the solubility product of BaSO4? Ksp of BaSO4 is concentration of Ba2 plus and concentration of SO4 2 minus. Solubility is given. Okay, this is the S and this is the S, so S square. Solubility, what is the solubility of this one? BaSO4 1.04 into 10 to the power of minus 5 whole square. So you will get 1.08 into 10 to the power of minus 10. Okay, this is the solubility product. Consider the following equilibrium. Given the following acids and their equilibrium constants, which is the strongest acid? Okay, acidity increases with increase in Kc. More the Kc value or Ka value, more the Ka value or the Kc value, more the acidity. And also acidity increases with the decrease in pKa value. Here Kc values are given, all these are acids, and this one 10 to the power minus 4, 10 to the power minus 4, 10 to the power minus 1, 10 to the power minus 1. This one is greater among all constant, all Kc10s. So what is the order? HiO3, okay, acidity order HiO3 is greater than, next to higher is HNO2 is greater than, HF is greater than HOPR. So which one is the strongest acid? HiO3 is the strongest acid since HiO3 has more Kc value. Choose the pair in which an effective acid-base titration is not feasible. For weak acid and weak base, the titration is not possible because at end point, at equivalence point, there is a sharp change in pH value, and also there is a fast change in color. We cannot identify the color change. There is no suitable indicator for weak acid and weak base. So the titration between weak acid and weak base is not feasible. Consider a relatively weak acid with pKa 3.90. A base is added to this acid in order to obtain a buffer with 4.12. Which of the following is closest to correct acid-base ratio in the buffer? Okay, we know the Henderson equation. pH is equal to pKa log the base A minus by acid, weak acid HA, and the log A minus by log HA is equal to pH minus pKa. What is the pH value? 4.12 minus 3.90. It will be equal to 2 to 0.22. So concentration of A minus by concentration of HA is equal to 10 to the power of 0.22. We have to take the ratio between acid and base. So acid HA by A minus is equal to 10 to the power of minus 0.22. So this one is equal to 0.603. This is the correct option. Which among the which change in the system will drive the equilibrium to the left in the reaction below? According to Chatellier's principle, suppose if you increase this concentration, the equilibrium shifts towards right side. Suppose if you increase concentration of products, the equilibrium will be shifted towards reactant side. Let's take the first option. Then an increase in the amount of N2O5. Suppose when you increase N2O5 concentration, so equilibrium moves towards right side. A decrease in the amount of NO3. When you decrease amount of NO3, the equilibrium will be shifted towards in such a direction in which there is an increase in concentration of NO3. Again, right side An increase in pressure. Suppose when you increase pressure, the equilibrium shifted towards in such a direction there is a decrease in pressure. Decrease in pressure means in which side there is a less number of gaseous molecules. From left side you have less number of gaseous molecules when compared with right side, so the equilibrium will be shifted towards left side. Here left side. An increase in volume. Suppose when you increase volume, the number of gaseous molecules decreases. So equilibrium shifted towards in such a way that there is an increase in number of moles. From left to right, there is an increase in number of moles, so there is a right shift of equilibrium. What is the correct option? C is the correct option. Thank you.